Hello everybody, now we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. This is practice problem 9.8 and the question is if voltage V that is equal to 10 cos of 100t plus 30 degrees applied to a 50 microfarad capacitor, calculate the current through the capacitor. Okay, so we are given the voltage applied across the capacitor and we are asked to find the current through the capacitor. So what are all available here? This V is there, that is equal to 10 cos of 100t plus 30 degree. Okay, and the capacitor value is given, that is 50 microfarad. And we know the formula that I is equal to C into dV by dt, isn't it? I is equal to C into dV by dt. So we are going to use this in phasor format. Okay, so what happens here? This is in the time domain. Up to this, it is in the time domain only. Okay, I of t, and here you have this dt. But for the phasor domain, we obtain this as capital I. Capital I is equal to that C into V into J omega. Okay, V into J omega. So what is C value here? C value is 50 microfarad. So 50 into 10 power minus 6. Voltage is, how do you represent this voltage in phasor form? Phasor form, this can be written as capital V, that is equal to 10 angle 30 degree. Okay, so it is 10 into angle 30 degree, then multiplied by j into omega value is how much? This is your omega. Okay, so that is 100. So what it is? I is equal to, here it is 50 multiplied by 10 power minus 6 multiplied by 10 multiplied by 100. Okay, then you have this j, then you have this angle 30. These are all the things available here. Okay, so here you have this 1 0 2 3 4. Okay, so here you have this minus 6, so that is equal to 5 into 10 power 4. It is 10 power minus 6 already available, and you can bring this j here, then this angle will be here. So this is equal to j into 5 into 10 power minus 2, right? Angle 30 degree. So I can consider this as of having two different format. So this is actually your I, right? And this one, right? This one is representing your rectangular form. And I can consider this as, polar form. Since we need to do the multiplication here, right? So in order to perform multiplication, we want both the terms to be in one polar. So we prefer to have the polar format only. So we need to convert this rectangular form into polar form. So what's the value for this when you consider this? I is equal to, so this is equal to 0.05 angle 90 degree, and here you can consider this as one angle 30 degree. Okay, two different terms, so we need to perform this multiplication only. Okay, so this is equal to performing multiplication. How would you do this? Just to multiply these two, that is the magnitude, right? So you'll be getting it as 0.05 only. Then for this case of this angles, you have to perform this addition. Okay, so that becomes, the angle is equal to 120 degree. So the capital I, that is equal to 0.05 angle 120. This is your answer actually, but it is in the phasor domain, right? So we need to convert this into time domain. So we want to convert this into time domain. So how do you do that? It is very simple. I of t, that is equal to, this is your magnitude, right? So you can simply write it as 0.05 and then cosine. Okay, cosine of, what is your omega here? Omega is given in the problem as 100, so 100t plus 120 degrees. Okay, so this much ampere we have. So this is your answer in the time domain. So this is the answer. or you can also write it as this magnitude. Okay, that can be written in terms of milliamps if you want, so you can convert it to as, it is 50, right? 50 cos of 100t plus 120 degrees in milliamps. Okay, multiplying this by 1000, that would give you this 50 cos of 100t plus 120 degrees. Okay, milliamps. This is your answer. Okay, thank you. Hope you have understood.